So, all right, this assignment is 4.1. It's basically 1 through 59 off. Okay? I'm going to go through as many of them as I can. Obviously, I can't do all of them. Right?
Did you just pick random ones to do first?
Yes.
Okay.
I didn't pick random ones. I picked ones that I thought would help you the most. Right? 1 through 59 is a lot. Right? So do I expect you to do all of them? No. I'm going to cover as many of them that I think you need. And as we go through, I might go, you know what? This batch we're not going to cover. We'll skip this batch. We've done that before, right? Okay? But for the most part, we're going to start with this. And we're going to look at what this has first. And this first part is 1 through 8. Okay? And 1 through 8 has basically determined whether the algebraic expression is a polynomial. To be a polynomial, right, you have to have an exponent that is a number, a whole number, right? Not a non-negative integer. Okay? A non-negative integer. That means square root is not going to work if it's the square root of an x. Okay? So 1/2 power, in other words, doesn't work for being a polynomial. Neither does negative powers. Right? -1. Okay? Or 2 or whatever it is. Or fractions. Polynomials that are in the bottom of a fraction. They are no longer polynomials. They're polynomial-like, but they're not polynomials. Okay? Alright, so when we look at this, it should be relatively easy. I look at this. Yes, it's a polynomial. Yes, it's a polynomial. Yes, it's a polynomial. Yes. Or wait, no. Why is that not a polynomial? And it's hard to see, but this is an x. 7 to the x power. Because the variable is the exponent, it is no longer a polynomial. Okay? The variable has to be term. Yeah?
Are we doing 4.1, 1 through 59?
Yeah. We're going to try. Okay? So, this should be MTS, Precal, homework 4.1. Sorry. Homework 4.1, questions 1 through 59. Oddish. You know. Alright, then the next one. Even though these are square roots, I know that they're square roots of numbers. They're not square roots of a letter, right? Or a variable. So therefore that's okay. I should realize that that's going to be x squared plus 3. At this point in your game, you should be able to look at that and go, that's x squared plus 3. Right? And so I know it's a polynomial. I look at this one and again, there's an x as a square root, not a polynomial. Okay? There's an x in the bottom, not a polynomial. Okay? So, but what about this one? Where they have k. And then they they say, hey, k is a fixed positive integer. That's going to be a polynomial, right? No matter what they put in, if it's a 3, if it's a 5, if it's an 8, whatever they put in, this will be a polynomial when it's done. Does that make sense? Okay, let's look at those a little bit more, because they want you to also say, okay, can you tell me the degree of the polynomial? Describe the polynomial, or name it, right? You got to be able to name it like last year. Okay? So this is a little harder, but same rules as this morning, what we talked about, right? You were there first period, right? So same rules as this morning. Is it a monomial? Is it a binomial? Is it a trinomial? Right? First degree, 0 degree. What's 0 degree? 1. Nope, 0 degree is 1, but what do we call it? 0. First degree is linear. First degree is, or 0 degree is constant. The constant. Constant. So it starts with a constant, 0 degree polynomial. First degree polynomial is linear. Second degree, quadratic. Third degree, cubic. Fourth degree, remember? You guys remember from last year? Fourth degree,
Polynomial?
Quintic or something.
Close. That's fifth degree. Quintic is fifth degree. Fourth degree is sounds like the change you have in your is in your pocket. Quartic. Good. Okay. Am I recording? So we got quartic, right? So we're going to try to do this. Pull it back a little bit. There we go. All right, so this I can rewrite, right? This is x cubed plus 1. So that would be a what? Binomial. What type? Cubic. Very good. So this would be a cubic binomial. Okay? What about this one? Now, we have to kind of put it together to know what it is, right? So in this case, honestly, I mean, they're not two perfect squares, so it's not going to be perfect. So it's like, okay, this is going to be x cubed, right? That's going to be plus x. This is going to be minus x squared, and this is going to be plus 1. So I'm going to be x cubed minus x squared plus x plus 1. See, I put them in descending order. Okay? So it's in descending order. 3, 2, 1, 0. Right? And then, what is this called? Polynomial. Good. It's a polynomial because it has more than 3, right? But what type of polynomial? Cubic. You can call it a third degree polynomial, but we like to call it a cubic. Okay? All right. This next one, not a polynomial. Okay? So you can't call it anything because it's not one. This next one, again, it's not one. Okay? So that was easy. Yeah? So let's look at the next portion. And the reason why I'm going to keep this on one video stream is because I already have it up there. I'm going to teach you guys synthetic division, something I did not teach you last year. I don't regret it, but I've seen a problem on the state test that had to do with synthetic division. And I'm like, well, I might as well show them. It's not hard. It's not hard. Okay? So this first problem right here, see how everything's in 4, 3, 2, 1, none? Right? 4, 3, 2, 1, none. And they're dividing by this binomial. Okay? Okay? And so what I did, 4, 3, 2, oh wait, no, it's 4, 3, 1, none.
Wait, again.
Yeah.
Why did you do 1, 3, 4, and 6?
He said the ones that
Because those are the ones that were most important.
Oh, so.
We talked about all of them. But we did the ones, because I have a time constraint. I only have so much time.
Okay.
Alright, so what they want you to do is called synthetic division. Okay? Or a lot of times it's called long division. Right? Okay? It's just like long division. But to do it, you need to set up a spot for each x. Notice how they didn't have an x for x squared, right? They had no coefficient for x squared over here, right? So I need to set a spot up, otherwise it won't work. Okay? So I set a spot up for x squared. 0x squared, right? It doesn't, that just means it's not there, right? But I put it there so I have a space for it. Does that make sense? Okay? Now all I'm going to do is say, okay, what times x is 3x to the fourth? What times x is 3x to the fourth? Yeah, what times x is 3x to the fourth? Huh?
3x to the third.
3x to the third. 3x to the third, right? And so I multiply this times this, I get 3x to the fourth, right? What do I do when I multiply this?
Well, how much is chicken strips?
Come on. 3x squared cubed is
Negative 6x.
negative 6x cubed, right?
Yeah.
Now watch this. Okay? I made this up a long time ago because students have a hard time. Draw the line,
Oh, Dan, he's just confused me.
change the sign.
Well,
Sounds like a song.
What I mean by that is this. I'm going to draw a line. And I'm going to change this sign and then just add them up. You can't subtract them. The problem is students mess up when they subtract. They don't remember they're subtracting and then they don't change the negative to a positive and then they run into trouble. You see what I'm saying? So if you can subtract them without drawing the line and changing the sign, go for it. It's okay. I just do this for students to make it easier for some of you. Okay? Alright, so draw the line, change the sign. And then just do it. This cancels every time. Because that's what you did. You set it up to cancel, correct? This next one may not. So these are opposite signs, so I'm going to subtract this from now to get a negative 2x cubed, right? Then I'm going to bring this down, plus 0x squared. Okay, and then I'm going to change my color again. Alright, what times x is negative 2x cubed?
X.
What times x is
Negative
negative 2x squared? See how it's in the square column? The x squared column? Then I multiply it, and I get negative 2x cubed, right? And positive 4x squared, right? And then I draw the line, change the signs, right? And I add them up. These cancel because we set them up to cancel every time, right?
Yeah.
And then 0 and negative 4 is negative 4x squared, right? And then you bring it down. Okay? There's no difference in long division than back in grade school, right? When you had to divide, 14 billion and 500 million by 24,000 or whatever they did to you. Okay?
No, it's a lot of zeros.
It's a lot of zeros. They always did something like that. Alright. What times x is negative 4x squared?
Negative 4x.
Perfect. Negative 4x. Okay? So that would be negative 4x squared. And negative 4x times negative 2 is positive 8x. Right?
Yeah.
And then we what? Draw the line, change the sign. Add them up, because these to go out, because we made them go away. Boom, I got x.
Boom.
I bring down the plus 5. Well, that's not going to work.
Well, I have a remainder.
Yeah, it's okay.
Why'd you put, oh, never mind.
We good?
Yeah.
So
Okay.
that's plus 1.
So it's just going to be 1, right?
Yeah.
Okay. And we were hoping that this would be a minus 2. If this were a minus 2, right? Then this would have been a factor
But it's not.
of this. But it's not a factor.
It's minus 10.
So it's plus 1, right? So we get x minus 2. And then we what?
Multiply.
Draw the line.
What?
Change the sign. Right? And then it's 7. Right? Did you forget to draw the line and change the sign? Oh. But then it's this number over what's left. So it's plus 7 over x minus 2. Now, is x minus 2, 7 over x minus 2, is that a polynomial?
Yes. I don't know.
No, it's in the bottom. That makes this a non-factor of the polynomial. Because you should be able to get a polynomial back, right? That's the whole key. If I had the answer key, I could grab one. I have one right here. I can grab one that actually is going to come out nice. Because honestly, I can't look at it and tell you.
What the?
3. What are we in? 4?
What?
Chapter 4, 1.
Change the sign.
Alright, 4, 1. They were- Oh, they all have. Oh, wait, here. No. They all have remainders. Okay. So let's go with. Here we go. Number 19.
Bitch.
Oh, this one's perfect. Alright, number 19. Right here. So they want to know, is this. You're supposed to be able to state the quotient and remainder when the first polynomial is divided by the second. Blah, blah, blah. Later on,
Oh my god.
oh, here they go. Tell me whether the first polynomial is a factor of the second. Okay? That's exactly what this one is. Tell me, is it a factor? So, is this a factor of this? No,
because
right?
There was a remainder.
Exactly, because there was a remainder. Can I erase that one now?
Yeah.
Can we start this new one, number 19?
Yeah.
Now, hopefully, as long as we do it right? But I think we did it because we came up with a remainder of 7, and so did the book. Right.
That's a lot of
I mean, I would hope so.
It's a lot of work.
I did that.
Yeah, I hear you. All right, can you read this to me? It'll go a lot faster.
X to the 5th.
Oh, wait, hold on. Read the first one.
Wait.
X cubed plus 1, right?
Yeah.
All right, then x to the 5th
Plus 2x to the 4th.
plus 2x to the 4th
Minus 6x to the 3rd.
minus 6x to the 3rd
Plus x squared.
plus x squared
Minus 5x.
minus 5x
Plus 1.
plus 1. All right, fun done. Holy cats. All right.
So is this one like number 9 or is it going to be different?
This one's just like number 9,
Yeah.
except hopefully this will come out nice and neat. But what they're asking us is it a factor of the polynomial? And if it is, what is the two factors? This is another way of factoring. Isn't this a lovely way of factoring?
Yeah.
Yeah, I just hate it too. All right, so how do I make this into a x to the 5th?
Multiply by x to the 2nd.
X to the 2nd. Notice how I'm writing that way down here? Why am I writing that way down there?
So you don't get confused.
No.
Because it cancels it out.
No. So it's in the x squared columns, so I don't get confused. She's right. All right.
What?
Because it's in the x squared column.
What?
The x squared column.
Yeah, I get it.
This is the x cubed
Yeah, I
column, the x 4th column, x to the 5th column.
After you put down the x to the 5th.
So when you multiply these, what is it going to be?
X to the 5th.
X to the 5th,
Yeah.
right? You multiply these, what do you get?
X squared.
X squared. Oh, well that's weird. That's going to be down here.
Wait, what?
Plus x squared, right?
Yeah.
Oh, snaps.
What?
So, what? So these are all going to be zeros.
Yeah, this is all 0.
You're lovely.
But what are you supposed to draw down, Dan?
Whoa. What do I do when I draw the line?
Change
sign.
the
Change
sign.
the signs.
Yeah.
That will help, maybe. Okay, so these first ones should cancel, right? And then I got the second one. What is 2 minus 0?
2.
Yeah, it's still 2. And this is still minus 6x cubed, right? Now what's this one though?
0.
Yeah, holy cats. All right. We got 0, so plus a 0x, right? Squared. And then we got to bring this guy down, right? Weren't we supposed to bring that down?
That's what I thought.
I hope so. I don't know. I'm just guessing. All right. Going with the guess.
So what are we supposed to do?
That's exact. Oh, what are we supposed to do? Oh, How do I get rid of this first one? What do I multiply x cubed by?
2x.
Oh, by x squared?
No.
By x.
2x.
By 2x.
Yeah, by 2x.
So positive 2x.
Yeah.
Oh, snaps.
Oh, snap.
Alright, so plus 2x times x cubed gives me 2x to the fourth, right? Plus 2x times 1 gives me what?
2x.
Plus 2x.
What?
Okay?
And you get
See how I put it way over there?
I don't know what's
I
X.
put
Wait, how'd you get that?
Wait,
Whoa.
the freaking.
The front. Yeah. The front.
I keep putting
Yeah.
2x minus the 6.
Wait, so it'd be 2x.
Ugh.
How do we do it?
Would it be 2x times x?
2x times 1
It's minus 2x.
would be, and 2x times x cubed, 2x to the fourth, right?
I somewhat get it.
Okay.
Wait.
2x times x cubed, x to the fourth, 2x times 1, 2x, right?
Oh, yeah, okay.
Okay? And then everything else gets filled in as 0, right?
Yeah.
0. Plus 0 x cubed plus 0x squared, right?
Yeah.
Okay, and then we're going to draw the line and change the signs. What? Okay, and then
Yeah, negative 7x.
be negative 6x cubed, right? Minus 7x, and then we bring down this last 1 plus 1, right? I don't know how we're not supposed to get a remainder on this, but we'll see.
And then goes into, so it's negative 6. It's minus 6.
So how do I get, oh, minus 6.
Yeah.
Okay. Minus 6, okay? And that gives me a minus 6, oh, I should use a different color than that. Let's go with minus 6, so that gives me a minus 6x cubed, and then minus 6, right?
Then you add it.
And then we draw the line, change the sign. Boom, boom. And so I get
0x squared minus 7x plus 7.
so I get 0x cubed,
Oh, x.
right?
No, x squared.
Minus 7x, and then plus 7, right? Is that right? And then that would be the remainder.
So they
Would
lied.
be, they lied, remainder of minus 7x plus 7 all over x cubed plus 1. Unless I didn't see it because it was on the next line. Oh yeah, that's the remainder. I thought they meant that that would be the polynomial.
Great.
That was the actual remainder.
Love it. So,
Beautiful, yeah?
Wait.
We just love this stuff. Alright,
Wait, what? Oh, I guess.
so that's basically what we're doing. Yeah? So